All right. So what we got here, we're doing our testing mastery uh, sessions. Really, this is kind of fundamental. It's one of the basics that we do in the work that we do. We spend more time, like we talked about before, more time reading code than we do writing it. And you're going to be maintaining software that someone else wrote, and and also the code that you're writing. You need to create tests for. So we're going to be talking about all kinds of different approaches to testing. Unit testing, where we write a small test. That's some people consider that what test after development. The program already exists. You need to write some unit tests to exercise it and make sure that it does what you say it does. And there's, of course, test-driven development, where you're writing the test and then writing the program from the test. Behavior-driven development, where you basically have a specification that you lay out, and from that specification, you then go and build the application. And then test-driven maintenance, it's like, okay, so how do I do TDD on a computer program that already exists, and adding tests to existing code, which we talked about a little bit, but I will go into more depth on that. The cool thing here is we're going to have a workshop where you get to play along. Okay, so let's start with unit testing, where basically the intent of it is to improve the quality of the code that you write. I mean, ideally, you want it to be more robust, more stable, and more readable, and testing helps to do that. Code that is testable is code that is maintainable, and you can have more confidence that any changes you make aren't going to break things when you have tests. Our reference for our discussion is Test-Driven Development by Example by Ken Beck. He's sort of, this book is what, 25 years old, maybe. And it's still an excellent reference for learning how to do test-driven development. There's two primary approaches to doing TDD. One is the Chicago approach, and the other is the London approach. And we'll talk about that later. But he does, since he's from Chicago, he talks about the Chicago approach. So, all right. So anyhow, why do we test? Well, we're trying to find the mistakes that are made before the customer does, and we want to be able to make sure that any changes that we make to the code, I want to feel confident that that's not going to break it. Hopefully, this is going to help us spend less time debugging. If you've got tests, they will show you where the problem is, and if you're spending less time debugging, you got more time to spend on doing interesting things, like researching and writing new code and coming up with cool algorithms and learning new skills and languages. And as we learn about TDD, we're going to learn how that will shape the design that we end up using for the programs that we write. And also, if you know about dopamine, that's the natural drug that we have that makes us feel so good when we do something that we should. And when you're doing something like test-driven development, it will let you get dopamine hits all day long, and you'll end the day more energized than you started, which is the opposite of how most of us end our days. Also, when you write a test, it'll help you to understand the problem better before you start writing a program to solve the problem. It'll bring up questions that you didn't consider, because you got to come up with a test for what it's supposed to do. And this helps you to do the design for the ultimate application up front. Um, and like I said, confidence in making changes. Also, um, it'll help you to avoid what's called gold plating. You know what it needs to do, and so you're not going to put in a lot of other things that it might need to do someday, no one will probably ever use. You'll be actually writing code that is useful for the ultimate user of the program. And the bottom line is you're going to learn what you really are supposed to be writing, um, rather than what you think you should be writing. There's Bruno Souza has a saying that you think you're thinking when you're thinking, but you're only thinking when you're talking or you're writing. And it's the same way with the coding. You think you're writing a cool program when you're coding things up, but the testing forces you to really think and make sure that you understand the problem before you start writing the code. And so one of my professors in college would say, don't make sure you think about this before you get your dirty fingers all over the keyboard. So there are different ways to test. Um, how do we do this? First we consider the intent of the program. What's it supposed to do? And what are we trying to do? We want to make sure that the quality of the application is high, and we want to make sure that the design of the application is flexible in the ways that we need for future development. And if you think about it, you want the code to be readable, because if it's not readable, then the next guy who comes along to work on it, which may well be you, won't understand it properly and will make changes that could break it. And that ultimately hurts stability, and it hurts your ability to get things done quickly, because you spend more time trying to figure out what the heck, what is this all about? And you don't have a confident understanding of what it's trying to do. And so you're not really making the changes in the optimal way. I mentioned here that performance is key, and performance, I'm talking about the performance of the developer. The performance of the application generally is not a problem. That's usually secondary. That comes along later when you start having many users, and you can go back and start looking at how to make it more performant. But if you write your code to be, more readable and more maintainable, chances are good it's going to end up being reasonably performant in most cases. And in the cases where it's not, it will be easy to find the places where it's less performant and make the changes successfully that you need to make it more performant. Also, reliability. I mean, that's kind of the whole point. We want to make sure that it works. And one thing that we often forget is that just like our code needs to be refactored as we learn more about how the problem is, and we learn more about how the design is growing, we need to refactor our tests and make sure that they are solving the problem that we need solved in an effective and maintainable and readable way, because tests are code too. All right, so the way we traditionally have learned to test is that, at least this is the way I learned in college, is you spend a lot of time up front designing what this program is supposed to do. You code it up, and then you go write tests to exercise it to make sure that it does what we claimed that it would do. And that's good as far as it goes, but the problem is that it may do things that it doesn't need to do. It may do things in a way that are incorrect, that we haven't thought about. There are cases that we haven't considered that aren't handled. And so that's why Kent Beck came up with this test-driven development approach, where the designs is, they call it emergent design. It just sort of comes out of how the program grows. So you first write the test. What should it do? Then you code up just enough to make that test pass. And then as that starts to grow and you start refactoring every step of the way, then the design sort of comes out. You say, oh, here's a better way to do this. And that's why we need to know our design patterns, so that we can know what patterns we're starting to develop and code to those. All right. So the point of testing, it's not an either or, it's a both and. We want to verify the quality of the code, and we want to make sure it's properly designed. Got here, tests are readable, maintainable. The test code is organized. The test checks what it needs to, reliable and repeatable. And it uses test doubles. If you know what a test double is, that's like a fake or a mock. That's basically a part of the program that, or a stub. It's a part that doesn't really add to the functionality of it, but it makes it more testable. Okay. Yeah. Shoot, I'm getting ahead of myself. What is a test double? A stub, fake, or a mock object? You
Yeah.
probably, are you familiar with these concepts?
No, no,
No?
that was, I was going to ask you exactly what it was a testable. And I'm just familiar with mock object.
Okay. So yeah, a mock object, you've probably seen like a JMock or something like that, where you create an object inside this framework, and you tell it, when I call this function, it needs to return that value. And but you're not actually calling the function, you're going to call this mock. And that's so that you can mask off a part of the application, like writing to a data, reading from the database, writing to a database, writing to a file, that sort of thing. The things that slow down the test, or things that you have less control over, and you can have it return a value that is consistent and that your test works. You know, I'm not testing the database. I'm testing my program. And I'm not testing the file system. I'm testing the program. So I don't need to go and make sure that everything gets written out properly. I just need to make sure that I've written out what I expect to. A fake is similar. It's sort of, you would, like, if you've got a clock, you're checking to make sure that the time is being handled properly. Well, that changes all the time, and you can't be sure that your test is is running on a clock. You want to make sure that something happens after 30 minutes. Well, you don't want to have your test sit there and wait for 30 minutes for that to happen. So you'll basically build a fake clock that you can call that will handle that. And then a stub is just something that it doesn't do anything, and you don't want it to do anything. You just want it to be there so that the program compiles. And
Okay,
you're not
okay.
going to be. I'm sorry.
No, that's okay. I'm just
Okay.
saying that it's okay.
Yeah, it's just you just want the program to compile. You're not going to be calling into it, and you want to get your tests to run. You want your tests to run quickly. Your unit tests, if you can't get all of your unit tests to run in a couple of seconds, frankly, you're not going to use it. You're not going to do it. You're going to fall back to your coding everything up and then writing a test later, because who has time to sit there, run a test, code things up to make the test work, go back and verify the test works, go back and refactor. You're not going to go through that cycle if you're if your tests take minutes to run. So let's talk about test-driven development. It's a fundamental discipline in our collection of software development techniques and tools. You've probably seen this loop before. You start by writing a failing test, and that in your JUnit it'll show a little green, a red bar at the bottom of the screens. Okay, so then I write just enough code to make the test pass, no more, and then I go in and refactor when I'm done. Generally, you want to you'll find a cleaner way to do it, or after you've written a few functions, then you'll need to go and refactor the application to get rid of duplication and that sort of thing. And also, this is a good time to go back and refactor your tests as well. When you're refactoring the application, you want to make sure that you don't change any of your tests, so that so you need to stay in the green. And then when you're refactoring the tests, you want to make sure that you don't change any of the application, so that your tests continue to work properly. So you want to refactor one at a time. But that refactoring step is one that it's very easy to skip. It's sort of like you've probably seen people that they forget leg day. They'll do lots of arm exercises so their upper body is big, but they got chicken legs. And so that's what I call refactoring, is don't forget leg day. Don't forget to refactor. It's very important. So yeah, the primary goals of a good test, it specifies a mistake or some function that's missing and needs to be added. And we want to be careful to write just enough code to make that test pass. And then this is from Kent Beck, ruthlessly refactor towards a simpler design. There may be something there that you say, I may need to use that in the future, and so I don't really want to get rid of it. Well, if you haven't needed it yet, there's a good chance you won't. And if you do need it later, you can add it later. And you may find that as you write the program and start to design it, it'll be easier to add that functionality in a better way later. I love this quote from Blaise Pascal. I've made this letter longer than usual because I've not had the time to make it shorter. And I know that I can be that way. I need to edit some of the, the things that I write, because I just have a tendency to go on and on. But we do that with our code as well. It's so easy. We have such a strong desire to go in and make things more complex than they need to be. All right, so the basic concept of doing test-driven development: no production code will be written before there's a failing test that justifies the existence of that code. So in this way, we will end up having 100% code coverage just by the way we're writing it. And we will be confident that any change we make will be there because we can justify the existence of the code. We're testing functionality that we know is there for a reason. And if something breaks that we don't know about, that's okay, because there's no reason for it to be there. Does that make sense? We don't care about bugs that we haven't tested because we haven't thought about it. Now, it may be a bug that we need to think about. In that case, then we will go ahead and create a test to make that happen. But yeah, this will make sure that we've got everything that is important covered. All right, steps for TDD. First step, basically there's the arrange, act, assert mechanism that we follow. First, you initialize the state of the application. then the act step is you perform some operation that should change that state. And then the assert part is we verify the result is what we expect it to be. So that's the how PDD is supposed to work. So, the way I like to write a test is I'll go ahead and I'll create the test and give it a name. And then I'll put in / arrange / assert. So I know I've got each step covered. And then I'll go and add the code that does that. Just to make sure that I'm covering everything. And I find this sort of documenting the steps that I plan to take is helpful as I write the program, me from forgetting things. Okay, so you want to practice? Of course you do.
Yes, sure.
All right, there is a site called cyberdojo.org. What I'd like you to do is go there and share your screen, and we will go and start. We'll walk you through a little exercise of TDD.
Okay. Okay, just give me 5 minutes to set up my computer. Just 5
okay.
minutes.
I
It's
should have
really
warned
quick.
you about this. Sorry.
No, it's okay.
So what I will do is here. I'm sorry. Yes. Let me put it on the screen where you can see. Cyberdojo, cyber-dojo.org.
Awesome, yes.
A really cool whatever site that has some nice things that make it helpful for doing collaborative coding and for unit testing. And what I will do, if you're going to share your screen, I will need to stop sharing my screen. So I will do that. You're ready? Go ahead and share your screen. Let me make sure you have the ability to do so. Boom. Now you have the ability to do so.
Awesome. It's starting.
Okay.
Yeah.
So how are you attending this if you don't have a computer running?
With my iPad.
Oh, with your iPad. Oh, okay.
Yeah.
All right. Well, that's pretty cool.
The more gadgets you have, the more.
What?
But the more gadgets you have, the more you think you're cool.
Yeah, absolutely.
Yeah.
And my wife likes to collect purses, and I like to collect computers. So
Yeah, me too.
but she has more purses than I have computers.
Yeah. Yeah, it is. For example, for me, it is really sad when I have to let a computer go. I don't know why.
Yeah.
Because you say, no, it no matter if it is old, I can put some Linux on it and it will run.
Right.
But you end up having like 2 or 3 computers that you really use. So
Yeah. Well, my wife, we had a computer that we've been using for a number of years. We do our taxes and personal stuff on it, and this past year it got to be just intolerably slow. I mean, you boot it and it would literally take 15-20 minutes to come up.
oh my
And she
God.
said, I need a new computer. I said, tell you what, I'll let you have my old computer and I'll get myself a new one that I can go and install all the latest updates on. The old one is much faster than anything you've ever had. So you'll be happy with it. And she agreed to that. So cool. She usually gets I remember some years ago I got a really fancy new computer, and she decided she liked it. So she took it over, and then
Awesome. Yes.
my daughter took it so she could do her gaming on it because it was the only computer fast enough to do that in the house. And then then when it got too slow to game on, she gave it to me. And so yeah, now like you said, it has Linux on it, so it can so it can run to do anything else. So I'll have a new Linux computer soon, and we can go and network them and do all kinds of cool stuff.
By the way, which of the Linux distros is your favorite?
I like MX Linux because I like the oh, what is that? Uh, the the user interface. It's I'm drawing a blank on it right now. I'm sorry, but it's the very simple, stripped down user interface, and it works best on these old computers that are, you know, they don't have the performance that they used to. Um, uh, Not XKCD. What's it called? Yeah, it's based on Debian, and it uses I'm just drawing a blank.
Scott, can you let me?
FCE, that's what it is. Yeah,
Yeah.
what?
From my computer, I tried to join the session. I don't know if you can let me. You can let me in.
Oh, sorry. Yeah,
Thank you.
there you are. Okay, so you're in. Good deal.
Can you hear me?
Yes.
Awesome. Yes. Okay. I will share my screen.
Okay, and I will put in the chat. Where do you go? Chat. There's the link to go to.
Awesome. Nice.
Yeah. All right, now go ahead and create a new practice. And let's do it the simple way. We'll start with the FizzBuzz. You know FizzBuzz, right?
Yep.
Probably written it a dozen times. So we just want to quickly work through the FizzBuzz exercise. So then you click that, you say next. Oh, I'm sorry. Yeah, duh. Now you pick the language that you want to work in.
I could. Okay. It could be
Java,
JavaScript.
yeah, whatever you like.
Okay.
Is that what you want to work in?
Yeah, it's the one I know.
Let's do solo.
Okay.
There you go. Okay.
Okay.
All right. So what we have here, this gives you just a quick introduction, built-in version control. So every test creates a new traffic light. If it passes, it's green. If it fails, it's red. If something else broke in the program, then it's going to be yellow. And you can click on any of the traffic lights to go back to a previous version if you want to. And the tests must complete in 10 seconds. If it takes longer than that, then your test is too long and it's not going to run. So we're not going to have to worry about that. You can go ahead and close it.
Okay, but I don't need to write the test in 10 seconds. It just completes.
No, yeah, the test has to run in 10 seconds.
Okay, awesome. Yes. Yeah. I was like, what?
Dang, you're good.
Yes, okay.
So here you go. We write a program, prints the numbers from 1 to 100. For multiples of 3, you print fizz. Multiples of 5, you print buzz. It's both. Print FizzBuzz. So that's what that's what it should look like. 1, 2, fizz, 4, buzz, fizz. Okay. So it calls every file hiker. You can go and create files that you want to if you like, but so hiker.js is your program. So turns A times B, hiker steps. Hiker feature is the description of the problem, or the no, I'm sorry, README text is the description of the problem. If you click on the left side, that's what we were just looking at. The hiker.feature.
And steps
is the test.
The test, okay.
Given when then. Okay. And then you go to the feature. And I think that's just the data that we use, right? Go to hiker.feature. Frankly, I've not looked at the JavaScript version of this before, so.
Okay, but I'm confused. Why hitchhiker selects from tiles? It's just example, or it's just why hiker?
Hiker because that's one of the tests that they use, and so they give you something to start with.
Okay.
So you can go ahead and run the test to see that it fails.
Okay. The tests are already written. Do I need to write some tests?
We will. First, we'll go ahead and show that it fails.
Okay, so I should run it right now, or I should test some code?
So click on the big yellow test button there. And it will show you that we expected something. Yeah. The score is 42. Nope. We expected 42 and it's really 54. Okay. Or no.
Oh.
It is 42. Expected 54 and it's 42. So if you go to hiker.js, click on the hiker.js over there on the left. All right, so you got A times B.
Okay.
So you got A and B. So let's go to hiker.feature. Scenario, the score is 42. Okay, so I see. Oh, this is we chose, the Cucumber version of JavaScript.
Yeah, but I don't think it's related to the FizzBuzz. It just
Are you familiar with Cucumber? Or what's the testing mechanism you use? Okay, so you know how to use Cucumber. All right.
Yeah, but for example, I'm confused a little. It just hitchhiker prayer Scrabble is not the same as doing FizzBuzz, right?
Right.
It's just an example, right?
Yeah, this is just an example. So we're just kind of working through the given example to make it work so you can see how it works. So you go to hiker steps JS and you see A, B, assert score equals expected score. So where do you provide the values here? When score, hiker, answer, parse int A and B, or an expected score. So I guess feature, is it feature? They spell 6 times 9. There you go. 6 times 9 is not 42.
Exactly.
6 times 7 is 42. So if you change that 9 to a 7, it should work.
Okay.
6 times 7 is 42. Yeah, so now 63. So we go back. So yeah, this is a different way of doing things. So go back to the feature. Yeah, it'll be 6 times 7. Should be 42.
Ah, yes.
7 times 6. Oh, we should have green now. So that's how we make it pass. All right.
Okay.
So now we want to start doing FizzBuzz. So we can go to this hiker steps JS, and we can say given. Let's go ahead and create a given when then.
Given when is 3, given
So yeah, when the number is
what?
a multiple of 3,
Okay,
so 3, then we'll print fizz.
exactly.
We can, when we're doing when we're doing TDD, we just basically come up with the rules. All right, all 3, we'll print fizz. Okay, given the number is a multiple of 3. Okay, it will print fizz will be the then part. Right?
Ah, okay, yes, yeah.
So you'll do and you want to change that fizz there.
Uh-huh.
Well, let's see here. We'll print. I'm thinking you'd need a backslash multiple thing. Well, I guess yeah, make it fizz because this is taking parameters. So it's going to call function A, right? When
Okay, so it will be function answer, right?
yeah, so the number is a multiple of 3 is actually a part of our when, right?
Okay. Okay, but given is when is multiple of 3, right?
Yeah. I'm depending on you for the syntax here because I'm very marginally familiar with Cucumber. So
Okay.
given, we need to generate a number.
Okay.
The number is a multiple of 3. But Cucumber Gherkin. We can use a different version of JavaScript. They've got 6 or 7 different testing harnesses that you can use for JavaScript if you want to. We just go back and do that?
Yeah, sure.
Okay. So yeah, just create a new practice.
Or we can do or we could do some Java if you want to,
It's
because
okay.
you're
That's okay. You said you're familiar with JavaScript, so I want it to be good for
no,
you.
but I'm also a little familiar with Java, so
Okay. So go to FizzBuzz,
okay.
scroll up right there. All right, next. And then, yeah, so you can scroll on down.
Yeah, Java.
You do Java. And don't use Cucumber because I'm not familiar with Cucumber.
Okay.
JUnit, Java 18 JUnit.
The unit SQLite or
No,
JUnit.
yeah, we're not going to be doing SQL. So JUnit, Java 18 JUnit.
Okay, yeah.
There. All right. So, okay. In here, we've seen this. You go ahead and run. You can see that hiker Java
Mm-hmm.
basically runs
Mm.
6 times 9, hiker tests as it should be 42. And you test it, and it doesn't work. Says, okay, we expected 42, but it was 54. So we go back to hiker Java. I say 6 times 7.
Okay.
Everything is okay. So now we can go to our hiker test and we can put together a unit test that's actually useful. Instead of life, the universe, and everything,
Mm-hmm.
what's the first thing we're going to need to do for FizzBuzz? I
It's
would recommend we say if we if the uh, if the number passed in is 1, we return a 1.
okay.
We'll write a function that generates the number we expect or the value that we expect. So we can say we can on line 12 instead of life, the universe, and everything, we'll say 1 returns 1. Okay. So int expected, it won't be an int, it'll be a string of 1.
A string?
Yes. Because if if you look at the README text, basically we're just going to print out a list of values, and
Yeah. Yeah.
let's just be consistent that it'll always return a string because fizz is a string. So line 13, you want to change int to a string.
Okay.
On line 13, oh, no, on hiker test. We're still on the test.
Yeah.
All right, so line 13, you want to change int to a string.
Okay.
Make it a capital STRING. Okay. And then actual will return, instead of an int, it'll return a string. Okay. All right. And so hiker.answer, we got to pass in something. So make it hiker.answer, and then we
Mhm.
pass in a 1. Very good. Now we go to hiker.java, and we have a public static string. And then we'll pass in an int. We'll just call it value, I guess, or number. Say int. No, this is Java. This is Java, so you've got to put the type int value. There you go. And so we return 1. There you go. And we run our test. That is the simplest thing that will make the test pass.
Oh my God.
Very good. Now you're looking at that and you're saying that's got to be a bug because that's not really computing anything. That's okay. We're just doing the simplest test to make the simplest code to make the test pass.
Okay.
And you can't get much simpler than that, right?
Okay.
So now we create another test. You can just go and copy this test and paste it in. We love copy paste in testing.
It should be from the board void or from
You need
test.
to include at test. Yeah.
Okay. Hi.
Oops.
Yeah.
There you go. All right. So you say 2 returns 2. String expected would be 2. Your answer is 2. Here we go. Now we should be able to run this test and it should fail.
Okay. Mm-hmm.
We expected 2, but it was 1. Well, let's fix that. So you can say, how do we solve this?
Okay. With mm, okay. If you receive a value here, you need to count, return the last value. It's like, okay, return value.
Yeah, that will work. But it'll have to be a string. So you'll have to say return string dot.
A string?
Yeah,
That?
string dot value of capital OF. So yes, lowercase f, yeah. And then pass in the parameter value.
Oh, nice.
Okay.
Oh, yes.
And we can run that test.
Oh, nice.
We're happy.
Mm-hmm.
We got hikertest.java. So do we need to refactor anything? That's just one line, so I think we're good.
Mm-hmm. Yes.
All right. So we can create another test. Let's see if 3 returns 3. Actually, 3 doesn't return 3.
Really?
What does 3 return?
It has to return fees.
You're right.
No, fees. Okay.
Run that and it should fail.
And let me just say
Oh, yeah, you
true.
got to change the title, otherwise it won't work.
Okay. Nice. I'm really, really like it. Thanking this. Okay.
Now we go here.
Uh-huh.
So now how do we fix this?
If mm,
If value is 3,
okay.
then we return fizz. Else, we return whatever.
Mm-hmm. But when I'm returning in JavaScript, like it could be like this.
Yeah, semicolon.
Okay. Let me just.
You can put curly braces around if you want. Yeah. There you go. You don't really need the else there, do you?
No, but I'm kind of.
Okay.
I almost.
Okay.
Okay.
Let's see if our test works now. Our test passes.
Okay. Yeah. The operator for comparison. Is this correct? Just
Oh,
one
I'm sorry. You have
equal
to say equal,
or
equal. I'm sorry. Yeah, that's an easy thing to miss.
is 2 equals, right?
Correct.
Okay.
Otherwise, it's an assignment. See how
Okay. Awesome. Awesome.
the
Thank you very much.
yellow light for us because the program.
Wow. This
Yeah.
is awesome. Yay.
Okay.
I'm getting excited to doing this.
Good.
So should I go with 4 or directly with 5?
Yeah, let's do 5. That's the
Okay.
next interesting one.
FizzBuzz, right?
Correct. Yeah, another thing about this is that if you're used to using an IDE,
Mhm.
you're used to filling all this stuff out for you, and you got to go and know how to do it. So let's run the test and see it fail.
Okay.
You have to have a red light before every green light.
Okay, okay, okay. Nice.
There you go. So it failed. So now you go in here, another else.
In JavaScript is else if. What is used here? If.
You can say else if. It's 2 words though.
Okay.
If value equals 5.
But if I need to do this, right?
Yeah, just say value equals 5. Equal 5. And you say return buzz.
Okay, let's try it.
Okay.
Nice.
Excellent.
I'm really looking to doing this. Awesome.
And now the next
Uh,
interesting one would be 6, right? Because it's a
uh,
multiple of 3.
yeah. Yeah, because it's a multiple of 3.
Yes.
Huh, I need coffee.
6 should return fizz.
Okay. Interesting. It will fail now.
Yes. It
Okay.
passed. Let's look at that. I could
Why?
just expect this. Expected actual. Well, interesting.
Let's see the code. 3 is not equal. 3 is not equal. 5.
How'd you do that? It's amazing.
Why?
Let's look at that test again. Test. Oh,
Test.
you didn't put an at test above it. It didn't run that test.
Oh, yeah. Sorry.
There we go. Now it failed.
Okay. That is so correct now.
Correct.
Okay.
Now
Mm-hmm.
we know the problem is that we need to, instead of saying equals, we can say value. You want it to be evenly divisible by 3, right?
Okay, but I need to do a value. Is it correct?
So yeah,
Roger?
yeah, value div 3 equals 0.
Exactly.
There you go.
Okay.
Now, if we run the test, it should give us green again.
Oh, not nice.
Very good. So then our next interesting one would be
50?
10
No, 10?
and should return buzz.
Yeah. I should be fizz here. Okay. It will fail.
Will fail.
Nice. Ah, I have my bones like Chewbacca. Nice. That
Then
is
you do
not
the same thing here. Value div 5 equals 0.
okay. Exactly. Nice.
There we go.
This is awesome, Scott. Because it really teaches you the feeling that little by little you are constructing something that is working as is intended to be, right?
Right.
Awesome.
So now take a look at hiker.java real quick. When you first thought of writing the solution to this problem, is that what you expected the code to look like?
No, I was thinking because I have done this in the past before. It was like but I was trying to remember the function instead of what I wrote before.
Yeah.
But seeing this code is like it's different from what I was thinking about.
Yes. And that's one of the cool things about TDD is that it forces you to think about the problem in a different way, in
Exactly.
tiny little
Yes.
steps.
Yes. Yes.
And you are confident, I am absolutely confident that this is generating the right answers for everything that we're testing.
Yes. Exactly.
So we've run a little long, so I will leave it for you to finish the problem if you like.
Mm-hmm.
I think you know enough Java to do that, or you can go ahead and try it in JavaScript, and we'll leave it at that. And but I really wanted you to get the feel for the flow of, okay, we're going to
Yes.
write a ridiculously simple test to test a ridiculously simple thing. And we're going
Yes.
to write a ridiculously simple piece of code to make it past that thing. Now
Okay.
we go and test it and we watch it fail, we watch it succeed. Is there something we can do to clean it up? Yeah. So, and that's the cycle you get into. And every single time that test passes, you get a dopamine hit. Every single
Yeah.
time you write the
Yes.
original test and it fails, you get a dopamine hit. You're going to be a junkie, you know? Dopamine junkie by the
Awesome.
end of the day.
Yeah, yeah, that is that, yeah, because I was kind of sleepy, because I'm really tired of the week.
Mhm.
But every time I did this and it worked and it didn't work and it was like, oh my God, it's like a game.
Yes.
And I was feeling I really I have to tell you, I really feel really energetic right now because I went to finish this and I went to continue and I want to do a lot of the other stuff that is here.
Mm-hmm.
All the tests that are here.
Yeah. Well, it's
Uh,
got
I want to
dozens and
try
dozens of
them.
how does even
Yes,
work.
yeah. And I think I think it's really, really, really good. So thank you, Scott. It is amazing. I will finish this in Java. I will do it in JavaScript, and I will try to write you something like a report or something and tell you this is my impression, this is my experience, and give you feedback on this experience. How about that?
Okay. I
Yeah.
wanted to one other thing. I wanted to show you one more thing here.
Okay.
So let's go to the next page. See? All right. So here's the homework. You do this TDD Kata, basically this the cyberdojo.org. There's also another site that I like. It's called Code Wars, and it basically provides a problem. Let me go
Okay.
ahead and bring it up for you. Um, we can log in. Oh, I gotta log in. Oh yes, with GitHub. Sign in with GitHub. Boom. So I'm right in. So, so basically, what you do is you go in here, and it's got a list of practices. You can also, compete with other people. But so here's a problem that it provides. Okay,
Okay.
and
Are you
it
sharing?
describes.
Because I'm not seeing what if you're sharing.
I am so sorry. All this computer technology stuff is just so complex.
Okay.
Thank you for letting me know. Okay, just want to do it really quick here. Boom. So basically, we did the TDD Kata Cyber Dojo is what
Mm-hmm.
you played with. This Code Wars is the last thing I wanted to show you. All right. So I've logged in. So when you create an account, it'll give you a recommended to try to rank up, and it basically describes the problem. And then you go in there and you decide you're going to go ahead and start working on it. And it throws up an editor, and there's your tests, and here's a description. And you go
Okay.
through and you do this. What you can then and you can use Vim or Emacs if you like that. But what you do is once you get it working, because it also makes sure that your tests run in a certain amount of time and everything. But once you get it working, then you can see how other people solved the problem. And
Okay.
and again, it's also you can use whatever language you can think of to do it. If you want to do it in COBOL, go for it. But
Come on, Scott.
but this is another thing. If you're looking to practice
Uh-huh.
working through katas and coding exercises and stuff, this is a lot of fun, and it can be really addictive because when you're finished, you can go and compare what you did to how other people did it, and you can learn other ways of writing the same code. And there's always someone who is smarter than you out there and has written it in a
Sure.
much more clever and better way.
Sure.
So anyhow, I wanted to share that with you, and so that will be the homework for the week. Is
Sure. I
finish that
will.
project we were looking at, and then get on Code Wars and play around.
How about this, Scott? I will do a challenge every single day, and I will at the end of the week I will send you my summary of the challenges. I
That'd
will
be
try to do
exciting.
that. Yeah.
Very cool.
Okay.
Alrighty then.
Awesome.
Okay.
I
Well,
will share. How about this? Make it like a tag, like code challenge, code daily code
daily code challenge.
challenge or something, and I
Okay.
will post it in the
Discord.
yeah, in Discord. And
Okay.
I done
That's a
this
great
pretty
idea.
good. Yeah. Okay. I will share that.
Okay. And if you want to collaborate on it, or you have any questions anytime during the week, feel free to reach out.
Okay, Scott, that's awesome. You have really when what how do you say when you it's like you have these bee the behave of the bees
Yeah.
and you shatter them and they get all excited. You kind of did that to me today. Like I was sleeping, I was You shattered my world today, and I'm really kind of
Perfect.
zzz.
Excellent. I've created a monster.
Yeah.
Deep
Yeah, yeah.
back in. Okay. Well, awesome. I'm glad to hear it. Thanks. And,
Okay.
so you have a great day and a great week, and we will look forward to talking again next week.
Awesome, Scott. See you next week, and have a good comeback to your life here in America.
Absolutely, will do. Thanks.
Okay.
All
Thank
right.
you.
Bye.
Bye.